The Indian Association of Structural Engineers, also known as ISTRUCT-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. ISTRUCT-E is registered under the Societies Registration Act 21 of 1860. ISTRUCT-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, ISTRUCT-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. ISTRUCT-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, ISTRUCT-E has collaboration with various international professional like-minded associations and institutions. ISTRUCT-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. ISTRUCT-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. ISTRUCT-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. ISTRUCT-E's activities are widely appreciated and known for quality technical contents. ISTRUCT-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. ISTRUCT-E's publications are becoming popular with time. ISTRUCT-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, ISTRUCT-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. ISTRUCT-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. ISTRUCT-E has its student chapters in several leading engineering institutions as well. Membership of ISTRUCT-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about ISTRUCT-E is available on its website www.istruct-e.co.in.
Vikas, shall we start?
Yes, sir. Yes, sir.
Dear friends, welcome to the webinar. Today's topic is steel, concrete, composite bridges decks, the common defects, non-destructive test evaluation, and repair strategies. The speaker is Dr. Lakshmi Parmeshwaram. She did her PhD in civil engineering from Roorkee University, now these days called IIT Roorkee, and has over 30 years of experience in research, teaching, and consultancy. She was formerly chief scientist, bridge engineering, and structural engineering, CRRI, New Delhi, and professor at CSIR. Her experience and expertise spans wind engineering, bridge engineering, and suitable construction materials. She has led aerodynamic studies on the Yamuna Bridge and other important bridges, wind tunnel studies on chimneys, cooling towers, and wind resistant design of towers. She has contributed to the bridge maintenance management system, mobile bridge inspection units, and structural health monitoring of bridges. She is author of over 100 technical papers. She has significantly contributed in making codes and guidelines for bridge design, construction, and maintenance. Now, our topic, steel concrete composite bridge decks have gained popularity worldwide due to the structural efficiency, cost effectiveness, and durability. These bridges combine the benefit of steel and concrete, leveraging the strength of both materials to create robust structures. Their application could be seen in the small and maximum span bridges to long span bridges such as arch bridges and cable stayed bridges. Steel concrete composite decks could experience various defects such as cracking, delamination, corrosion, and fatigue damages, etc. By using non-destructive tests and evaluation, engineers could assess the condition of the composite decks, identify the cause for the defects, and prioritize the repairs to ensure structural integrity and safety. Thus, the webinar aims to improve the understanding of common defects and repair methods that would help engineers to extend service life of steel concrete composite steel decks. Now I request Dr. Lakshmi to kindly proceed. Dr. Lakshmi. Hello? Vikas?
Yes, sir. I think there is some problem with
It doesn't
internet.
matter, let's wait. Ask
Yeah.
the person to
Hello?
wait. Madam.
Yeah. 1 minute.
Please take your time.
Sir, are you able to see my screen?
Yes, please.
Yeah. Thank you, Dr. Ravan sir and IAS Truckee for giving me this opportunity. And today I'll be discussing about the steel concrete composite bridge decks, which are gaining a lot of popularity nowadays. So the common defects and what type of non-destructive testing and evaluation can be used for identifying the root cause and the repair strategies that I'll be discussing. And the presentation I'll be discussing about why like this steel concrete composite bridge decks are becoming popular, and the defects can be either during construction or during in service. So what are these defects and the NDTE and repair strategies? But main focus will be more on the steel component of the bridges, because steel concrete composite section basically it provides an efficient and cost-effective form of bridge construction. That's why it is gaining popularity. Actually, we know that steel that is strong in tension and weak in compression, and concrete, on the other hand, it is strong in compression and weak in tension. So we are trying to combine the effect of both these materials' strength, and with which we are able to achieve larger spans. So that is what we are trying to achieve. And if you see that since last two and a half decades, large number of bridges are being constructed in urban region, and you can see that this is a multi-span I-girder bridge, and it has basically you can say that 1, 2, 3, 4 longitudinal girders are there, and they can be provided with either cast in situ deck slab, or like they can be provided with a precast deck slab, which is fully precast deck slab, or like they can be provided with partial precast along with a cast in situ deck slab. And this is another example. And in the previous example, you see that it is there are 2 piers you can see here, and the space beneath this particular flyover is not being used for any traffic. So in a place where there is a lot of congestion and also scarcity of land, this sort of arrangement is not suitable. But in the second case, you can see that there is single pier in which a 6-lane deck is being supported. And again, you can see that the longitudinal steel girders are there, and they are connected through this lateral bracing. And you can see the some splices also here, and the web stiffeners are also seen here. And this particular bridge is provided with a precast deck slab with only some stitching in between. And another example is the bowstring bridge, where like again like you can use this steel concrete composite construction. Again, like you know that in that case, like not only the deck, the deficiencies are to be seen, but on the arches, the connections, etc., the deficiencies are also to be seen. But the steel concrete composite construction that is widely used in the case of long span bridges such as Hooghly Bridge, you can see in Calcutta, which has a 35-meter wide deck, which is of steel concrete composite deck, which is a 6-lane bridge and constructed way back in 1992. So you can see that this is becoming quite popular, and not only one cable stayed bridge in our country, but if you see the signature bridge in Delhi, or like the Zuari bridge in Goa, or the one which is under construction, that is the Kapurthala cable stayed bridge, which has a wider deck of more than 38 meters. They are all steel concrete composite deck for the main span. Now, why like these structures are becoming popular? That is because of design flexibility, and you can see that in compared to the same span length of concrete bridge, like it has a reduced superstructure depth, and they can be easily standardized, and also like by standardization, like you can achieve cost effectiveness, and they are easy to handle and transport. These girder components and faster in erection and more durable, because steel, you know that it is a factory produced item. So unlike the concrete, like the properties are like much more known and also under control, so and reduce maintenance for such type of bridges. And also, like you see that for the design, like you have this IRC 5 general features of design, IRC 6 for the load and load combination to be taken, then IRC 24 for the concrete deck, and IRC 22 2015 that is gives the design criteria for composite construction. And now, like, there is an explanatory handbook with worked out example, that is IRC SP 120, that is an explanatory handbook for IRC 22 2015. And then, like, you have the IRC 112 2020, that is for the design of concrete bridges. But recently, like this IRC SP 144 2024, that has been brought out by IRC for giving the detailing about the steel bridges, because detailing the connections, that is very important in any steel structure. So for bridges, like now there is a dedicated guideline for that. Then there is one for the fabrication and erection of steel bridges, that is IRCSP 104. And also one more guideline is being brought out, that is for the modular steel bridges. So again, that will be using a steel concrete composite deck. And as far as the repair rehabilitation aspects are concerned, like we have this IRC SP 74, that is for guideline for repair and rehabilitation of steel bridges. Then IRC SP 35, that is for the bridge inventory inspection and maintenance management. IRC SP 40, that is for repair, strengthening and rehabilitation of concrete bridges. If you see them, like you will see something dedicated to steel, something dedicated to the concrete, but not actually something related to the composite action. So that is what, like, I thought that this will be a relevant topic for today's presentation. So composite means that the steel structure of the bridge is fixed to the concrete structure of the deck so that they can act together, so thereby reducing the deflection and increasing the strength. And how it is done is through the shear connections fixed to the steel beam, and then which is embedded in the concrete. So basically the composite action is achieved through the shear connectors. So if you see IRC 22, you will see that the flexible shear connectors in the form of either shear studs, they can be provided, or like the channel connectors, they can be provided. And basically they develop the integral action and derives resistance to shear through the bending of the connectors themselves, and they don't allow the slab to lift from the girder flange through the anchorage action. Basically, the steel girder, that is the top flange of the steel girder, is anchored with the deck slab through this shear connector, and they can be of two types basically. And IRC 22 gives like what should be the spacing of the shear stud and how the design of the shear stud to be done. And you can see that the shear studs are basically welded to the top flange of the eye girder, or even on the you can say the box girder. So for the design purpose, like you have the ultimate static strength of the shear connectors that has been provided for both stud connectors, varying of the diameter between 12 to 25 millimeter, and the height of these stud connectors are also varying, that is 65 to 100 mm. and they will be embedded either in concrete of strength 25 MPa or 30 or 40 or 50. So basically this static strength that is determined by the means of push-out test. So for the design purpose, for different concrete strength, for both stud connectors and for the channel connectors, the channel again, like it has to be, because it is a rolled steel section as per IS 2062, the values are given. And you can see that as the strength of the concrete increases, the ultimate static strength of the shear stud is also increasing, and also with the increase in the diameter, again, like the ultimate static strength is increasing. But they say that like many times, like we use the these values can be used for the design, and basically they are not applicable for the composite slab using profile deck. But nowadays, like we see that for most of the deck construction with the steel, concrete, composite bridge deck, like the profile sheaf, they are used. So, but in that case, they say that like the push-out tests are to be carried out as per this IRC 22, but I have never seen that these tests are being done in actual practice. That is a cause of worry for me. And again, like you can see that ultimate strength and the fatigue strength, these two are governing the design of these shear connectors. And again, like the shear connector material, depending upon how many fatigue cycle the strength values are given. So they are used in deciding how many number of shear studs or the channel connectors are to be provided. So basically, we have to see how the shear connectors are to be distributed in the zone between maximum and zero moment section. And also, like generally the fatigue consideration that will exceed the requirement from the flexural strength, that is the number of connectors which are required for fatigue consideration will be much higher than that for the flexural strength. So because you can see that these two tables, that is table 7 and table 8 of IRC 22, they are to be used in getting how many numbers of shear studs are to be required. And also the detailing of the shear connectors, that is also provided, because I have already told that actually like the shear connectors are to be welded, and the diameter again varies from 12 mm to 25 mm. So if the D is the diameter, basically like the stud width, top width, that is 1.5 D, that is minimum. And also what has to be the height, actually it cannot be lower than 100 mm or 4 times the diameter. So if 25 mm is used, at least it has to be like 100 mm. And automatic stud weld is done. And also like details of the channel connector, again that is given. And also like the diameter of the stud connector welded to the flange plate shall not exceed twice the plate thickness. Height already I have discussed. Diameter of the head also I have discussed. The leg length of weld joining other type of connectors to the flange plate shall not exceed half the thickness of the flange plate. So channel and angle connectors shall have at least 6 mm fillet weld placed. So basically they are connected, this if you are using an angle or channel connector, like the 6 mm fillet weld has to be used. And also the clear distance between the edge of the flange and the edge of the shear connector shall not be less than 25 mm. And also how much cover to be provided for these shear studs, that is 50 mm cover to be provided. So all these details about the how the shear uh, studs or connectors are to be provided, they are given. And also, like the precautions, that is, we need to prevent the separation of the girder from the concrete. So how that can be done, that is also given in IRC 22. And it is given in both the cases, that if there is a haunch is provided or the haunch is not provided. So in both the cases, how it can be prevented, that is included. So you can see that this is the box girder. Basically, the box girder is used for larger span than the eye girder, because you have two webs to take the shear, and you can see that the shear studs are provided in the flange, and even you can see that there are some plan bracing also provided in this case of this box girder. So shear studs shall be used at interface of in situ deck slab and girder. As I said that the deck slab may be in situ or it can be precast also, and girder to transfer basically the longitudinal shear. So this is one very important element, but I have never seen in any drawing much details given, and even in the field, like wherever I have inspected, not much details about the shear state or how they have been checked in the field, etc. Though they are some of the details like the spacing or the diameter, etc. are there in the drawing. So when you select a particular steel for construction, like basically you have hot roll, medium and high tensile steel specification that is covered in IS 2062-2011. So basically the parameters to be considered are for the material availability, reflection requirement, weldability and fatigue requirement. And basically the weldability is checked using the carbon equivalent. So the carbon equivalent is determined based on the chemical analysis, like what are the values of carbon, manganese, chromium, molybdenum, etc. So if the carbon equivalent is less than 0.45, that ensures good weldability. So the type of electrodes which are used for the welding purpose, that again depends on the carbon equivalent. So these are some of the type of steel like which are given in IS 2062 and widely used. And you can see that there are 4 different category A, BR, B0 and C. And the yield strength, though like there are even higher grades given in IS 2062, like these are some of the one which are widely used. And CVN, that is basically, it is the Charpy V-notch test, and that CVN number at different temperature, like for different grade of steel, and the test is done at different grade. So those values are also given. So what you have to understand is that the defects in steel concrete composite bridges can be minimized, like if you are practicing a good quality control. So that is the first step, that we try to prevent the defect. That has to be our motive. So structural steel has to conform IS 2062, and all the steel section used for fabrication, it must have the MTC or the mill test certificate, and record all cast mark numbers, heat mark numbers, etc. after the procurement, and you do a physical condition check, that is the visual inspection, to see the straightness of the steel supply, pitting, rusting, rolling defect, if any, that can be identified with visual inspection. Then cut a sample piece and send it for testing to independent test house, and compare the test result with MTC. Now the question comes, this is a destructive test, so what are the tests to be done? Basically the tensile strength testing that is to be done. So the yield stress, the percentage elongation, bend test, then the V-notch testing. Basically the toughness That is the material's ability to absorb energy without fracturing. So this Charpy V-notch test and the tensile strength testing, both are the destructive testing. So they are to be done. Other than that, like the chemical analysis of the steel sample is also to be done based on IS 2062. So basically these are mechanical test and chemical analysis. They are basically the destructive type test which we do, and then compare the property with MTC. That is the first step. Then, like if the steel plates are thick, then we go for this ultrasonic flow detection test to see whether there are any internal flows. Then, like check the dimension, again like the testing of shear connectors of different diameter from the external lab. This also like not many people are doing the actual testing, but I think this has to be followed as a good practice. Then if you and we are using the HSFG bolt, again like the dimension of the bolts to be checked, then external laboratory testing, chemical analysis, strength properties, not only of the bolt, nut, washer, etc. is required. And welding consumable, again, like as I said, that it is based on the carbon equivalent. So that has to be seen. Then another important aspect with the steel structure is that the durability depends on how we are providing the protective coating. And the protective coating can be either with the help of paint or it can be some metallizing. So if you are using the paint, then the verification of manufacturer's test certificate, inspection test as per specification, that is the weight, that is for 100-liter paint, what will be the weight, then how much is the drying time, consistency, dry thickness, and what is the rate of consumption. All these things are important. And what is essentially is that we have to maintain the record of all test results and complaints. Then comes the cutting, which can be done by flame cutting. Then after flame cutting, then dye penetration test or magnetic particle test. So these are again like non-destructive tests, which are to be performed during like the process of fabrication. That is during the cut, after the cutting, this has to be seen that there are no cracks, because steel is strong in tension and we don't want any crack to be there in steel. Then edge preparation, shearing, groping, sawing or flame cutting and grinding can be done. Then there are stiffeners and gussets. The sheared edges of plates, etc. to be ground to smooth profile. Then manufacturing, again here you see that like the layout of components and joints, the dimensional check has to be 100%. Jig and template, 100% check. Cutting, straightening, edge preparation, again 100% check. So dimensional check, visual check, all these things are very important. Even the rivet or bolt hole. Nowadays rivet connections are not being done, but bolt connections are being done. So the diameter of the bolt holes like shall be 1.5 mm larger for bolt up to 25 mm diameter and 2 mm for bolt with diameter more than 25 mm. So the bolt hole, their dimensions, like whether that is as per the drawing, etc. to be seen. So this shows like how the dimension structure.
मैम आपका स्क्रीन शेयरिंग आई थिंक
स्टॉप हो गया, so, अपने आप हो
यस
गया।
मैम, यस मैम।
अभी दिख रहा है?
Yes, now it's okay.
हाँ हाँ हाँ,
यस
पता नहीं अपने आप आ गया।
कोई
Storage
बात
and handling, that is another important aspect. Actually, when you go to the site, that many of these materials are not properly stored. Actually, the raw steel that has to be stored free from dirt and shall be protected from corrosion and distortion. So many places we see that there is water and it is in contact with water, and electrodes which are used for the welding, etc. They are also to be stored in dry and warm condition. Bolt, nut, washers, etc. They should be placed in racks which are to be above the ground on gunny bag with protective oil coating. Handle raw steel with proper sling so as to cause minimum damage and distortion. So even the fabricated components, they have to be handled or stacked in a manner that they are not subjected to any bending or deformation. So we need to pay a lot of attention even to storage and handling of the material. So now coming to the defects in concrete and steel during the construction, and I'm sure that in many of the lecture or many of us, we are more familiar with the defects in concrete, but not to that extent with the steel. Basically, we have to understand that structural steel, actually, it is not encased in concrete, and it has the defects which are related to poor quality control. That's why I gave the importance of even storing, handling, etc. And also like how the cutting and other aspects are to be done. So poor quality control, loosening of connection, as I said that the bolt connection, like maybe it can become loose, maybe because of some impact damage or because of settlement, etc. Or like they are exposed to the aggressive environment in which they are placed. Because in the case of concrete, the steel is embedded inside the concrete and it has a cover which protects it from the aggressive environment. Still, it gets corroded. So there is a difference. So with respect to the quality control, actually there has to be a welding procedure sheet which gives the specification of parent material, electrodes, wires, wire flux combination, and the location size of the actual length of the weld. For example, like you have the built-up sections which are used mainly in the bridges, so top flange, bottom flange, and there is a web, and you can see that the fillet weld areas where they are. So these are the important points like where the welding will be done. So whether the weld has to be shop or field, and what is the current voltage and other parameters to be used, what is the welding procedure, whether some preheating, post-heating, etc. required, inspection and testing requirements, all these things are to be provided in the welding procedure deck. And as I said that the gap between the various components to be checked, and also during welding, what is the temperature and if any preheating is required, such things are to be seen. And what are the defects which are likely to happen to the weld? Because that is one important aspect to be seen. So one welding defect, that is the undercut. Basically, undercut is a defect that is, you can see that some sort of a groove is formed at the edge of the weld, and basically it reduces the base material thickness and it weakens the weld strength. So that is undercut. Another is the porosity. Basically, the welding porosity, that is a defect caused by the gases being entrapped in the solidifying weld material, resulting in some internal holes or some cavities, etc. are formed. So that is what we call like a porosity. So basically there are different reasons for that. That is, contamination may be from oil or grease, or maybe from the moisture, or it may be because the welding is being done on a windy day, or maybe some inadequate or turbulent shielding gas flow, etc. So there could be many reasons for that. Then lack of penetration or the poor penetration. That is, the welding, you can see that the welding material has failed to fully fuse the root of the joint. So that leads to a weaker weld. So that is the lack of penetration. And another is the lack of fusion. And lack of fusion is a more critical issue. That is, the filler material fails to properly bond with the base material or previously weld layer. Another is the slag inclusion. That is some non-metallic solidified flux that get entrapped in the weld. So again, that creates a weak weld. So these are the defects which are in the weld. And basically, the crack, as I said, that it is not acceptable, and whether there is a crack or not there or not, that can be confirmed by magnetic particle inspection. Then undercut up to 0.8 mm, that is acceptable, and you can fill and grind smooth. Crater is also not acceptable. So we have to fill by weld deposit. Porosity, actually 1 pore of less than 2.4 mm every 100 mm length, that is permitted, but more than 2.4 mm, that is not acceptable, and it has to be required. So these are some of the defects, but there is a need to find out whether the welding has been done properly or not, and for which, like, you use the non-destructive testing. Then we discussed about the shear studs, which are very important for transferring the longitudinal shear. So the shear studs, they are actually welded in position. So basically, there is a ring test which is to be done by striking the side of the head of stud with 2 kg hammer. So if you get a ringing tone, that indicates that there is a good fusion, and if it is a dull sound, that indicates lack of fusion. So lack of fusion, that is, as I said, that is a critical issue because the filler material has failed to properly bond with the base material. So that is what we are trying to check here. So the stud weld shall not show any sign of crack or lack of fusion. Crack, there should not be there. Lack of fusion, not acceptable. So replace the stud which have failed the test. Another is the bend test for shear. We said that this shear resistance is obtained by this bending of these shear connectors. So the selected stud head stroke with a 6 kg hammer shall be capable of lateral displacement of approximately 0.25, 1/4 height of the stud. That means, like, if it is a 100 mm, then 25 mm from its original position. After bend test check, any crack or lack of fusion is there, that has to be checked, and it has to be done. That is 1 in 50 has to be tested. So these 2 tests have been prescribed, like how this has been welded, whether the weld has been done properly or not. And another important aspect is as I said, the painting. So the surface preparation is very important, and also the cleanliness of the surface and the roughness of the surface. These 2 are important, and there are different type of paints. And as you know, that in the case of steel structure, like, periodic painting is required, but nowadays, like, you have C5 painting, which have, say, longer life. So you may require not in every 5 years, maybe after every 25 or 30 or 40 years. So such paints are also available. So what type of paint to be used, that depends on the exposure condition in which the structure is situated, and IS 800 also gives the various exposure condition and how to select a particular type of painting. Or the metallizing. Basically, metallizing for the girders, that is, used like if the bridge is being built at a location in close to sea or creek, or which is subjected to some salt spray. But one thing you have to remember, that no part of the work shall be painted or coated or packed or dispatched before inspection and approval by the inspecting officer, because if there is any crack or anything is there, if it is painted or coated, we may not be able to see that. So painting and metallizing, like lot of precautions are to be taken. Then shock painting, when you do, basically the temperature and humidity at the time of painting, that is important, because temperature affects the drying and curing time, and humidity affects basically the condensation. And for each layer, like you have to measure the thickness of each coating layer to check the evenness of the paint. Again, the painting, you may say that this is not a structural engineering aspect, but to achieve a durable structure, like we need to pay attention to the painting or the metallizing, that is important. But even the data related to the dry film thickness measurements, etc., they are not, I have not seen them in the field. So that's why, like, I thought that this is important to be mentioned. Then, as I said, that like the you have the primer coating, and then like secondary coating, etc. So how much thickness, how even you have applied the paint, that is important. If you have a thickness which is more than specified, again from that portion the paint may get peel off. So we don't want that more excess thickness of the paint also. So this FHWA field manual for bridge paint inspection, that states that the average of the measured DFT value shall not be less than 80% of the specified thickness, nor greater than 150% of the specified thickness. So you can see that like different type of steel girders are there. Either they are provided with some protective coating in the form of layers of painting or with metallizing. So the protective coating damage, and that is one root cause for initiation of corrosion. So that we need to understand. And the many factors, that is the pre-treatment error, that is the substrate is not properly blast cleaned. So that basically leads to the corrosion and also spreading of the corrosion under the paint after the initiation. So maybe like you have a painted surface, but if the substrate was not properly prepared, then beneath that painting, like you have a corroded surface. Then low dry film thickness, that is the DFT measurement, that is important. So the coating has poor barrier property if you have a low dry film thickness. So the corrosion again initiates under the paint. Edge retention, low DFT over edges, weld retention, low DFT over weld, or cracking, that is the coating itself is cracked, or there are some pinholes or the small holes in the coating during application that may be caused by outgassing or solvent evaporation. Even the pinholes become a local point from where the corrosion initiates, or like chemical degradation of, that is the coating itself is prone to the environmental attack, that is chemicals present in the environment, they are attacking the coating itself. Or overlapping joints, that is the bridge truss work where jointed by bolting and not welding, water penetrates to the crevice over time and corrosion initiate. Or mechanical damage, actually some object is hitting the surface and it is causing damage to the paint. Or galvanic corrosion, like when you have a stainless steel which is attached to the painted steel. See, for example, now structural stainless steel, they are also being used for bridge construction. Then in that case, like your shear studs, etc., they are also to be of structural steel. Cutting edge, like cutting or drilling in the steel after paint application. So again, that can damage the coating. So the protective coating, if it is damaged, then that will lead to initiation of corrosion. So what are the factors which affect corrosion in steel bridges? Basically, the time of wetness, that is how long the surface is wet, and alternate wetness and dryness, and the atmospheric pollution. Like for example, like you have the concrete with a steel embedded in it, there the corrosion may be either due to carbonation and or chloride attack. But in this case, it is the atmospheric pollution, either because of sulfate or chloride, that the surface is getting corroded. So sulfates originate from sulfur dioxide gas produced during combustion of fossil fuels, because we have a lot of industrial environment now. So that's why, like not only in the marine environment where there is chloride is mainly present, even in the industrial area, because of the sulfate, like the corrosion of these steel bridges are happening. And you can see that, like you can see the corroded part, or like you can see if some rivets or bolts are missing, etc., by naked eye also. Even the loss of camber is there for a bridge, that is also seen like without any help. So the various type of defects, like defect of protective coating or corrosion, basically they are due to the exposure to the moisture, or chloride attack, or chemical attack, as I said, that the sulfate attack, or the crack, or the deformation, or maybe the loosening of the bolt, or missing of the bolt, maybe because of the cyclic load to which the bridge is subjected to, or impact damage, or support settlement. And one thing I want to tell you, that like the steel concrete composite bridge, there the vibration amplitudes are much higher than that of the concrete bridge of the same span. In fact, we have carried out a study to find out the frequency and amplitude of oscillation. So the vibration, again, that can also lead to this loosening of bolt, etc. And as far as this concrete is concerned, like IRC SP 112, which gives the quality control aspects of road and bridges, but there is only one sheet which says that, like the surface defects like honeycombing, sand streaks, or air bubbles, cold joints, etc., to be noted. Again, this particular form, though it is there in that particular guideline, not being followed at the field. But we have to understand that even though the steel, that is the reinforcement steel, which is embedded in concrete, that is that gets corroded, as I explained earlier, because of either carbonation or chloride attack. So you can see that first some cracks are developed because the rust which forms, that has some more than 8 times the volume of the steel bar which is intact. So it exerts pressure on concrete, and because of which the cracking develops, and you can see that the crack which develops and it gets widened. So you can see a longitudinal crack along the length of the rebar when you inspect the bridge. And again, there could be some delamination. The delamination is that there is separation of concrete from steel, but the concrete is still there. Then comes the third phase, which is the spalling, that is the concrete tries to falls off, after which, like you can see, the exposed reinforcement. So if you see the stress strain graph, like when it is intact and the damage, like the strength of the concrete is reduced. Similar thing happens in the case of steel, because steel has become from ductile to brittle, and again, like the strength has reduced, and also like the bond deterioration also takes place. So three things are happening. That is, there is degradation of concrete, degradation of steel, and also the bond deterioration that is also happening when the steel rebar, which is embedded in concrete, is getting corroded. So why it is happening? You all know that the honeycombing, which I said, that could be one reason. Proper compaction is not there. That could be one reason, and concrete otherwise also is not uh, uh, like impervious, but there are interconnected pores are there. So these are the reasons which leads to the corrosion when it is exposed to moisture, as well as like some aggressive uh, agents like chloride or carbon dioxide are there. Now coming to the non-destructive testing and evaluation, basically like visual inspection, like there, like you can see the damages like in an advanced stage, but like subsurface cracks, if they are there in weld or in otherwise also, like in the girder in some location, like there, if you want to see, some NDTs are required. So for steel structure, basically, like for external surface defect, we have visual testing, dye penetration testing, magnetic particle testing. In fact, these two we see that even during the fabrication itself, like these are being used. Then another is the eddy current method. Then for subsurface defect, like ultrasonic testing or acoustic emission test or infrared thermography method or radiographic testing or laser testing method. So these are the methods used for steel structures. So visual inspection, basically whatever we see with our naked eye, and again, like it all depends on your eyesight and where you are, whether it is very close to the structure component or you are standing at a faraway place, or you may require some aids like magnifying glass or binoculars, boroscope, etc. That means like the visual inspection can be either close or remote inspection. So if you see the bridge inspection methods, like you can classify them as four, like visual inspection. Another is the acoustical technique, then the visual testing and coring and chipping. So visual inspection, we said that like you see using the basic tool, and maybe you can have some light, etc. Then sounding hammers or tape measures, plumb bob, binoculars, etc. This acoustic technique where like you can do some hammer tapping to see, even we said that you tap the shear connector to the base material and see whether you get a ringing sound. That is also acoustic technique. So to check any delamination, either you can use this chain dragging or hammer tapping can be done, or visual testing, as I said, that like the boroscope can be used, or coring, like you take some core of concrete to assess the corrosion damage, or like what is the chemical or mechanical properties of the concrete, like the compressive strength you check, or you find out whether carbonation has happened or chloride attack has happened, etc. So some magnifiers, binoculars, some boroscope, etc. can be used. Even these are some of the optical aids which can be used for visual testing. For concrete deck slab, you see that most of the things like you can use with visual check. Only crack, if you want to measure what is the width of the crack, maybe crack meter or gauge to be used, because the repair method, that will depend on what is the width of the crack, and also like you may have to see whether the crack is active or passive. So again, like some telltale glass can be fixed and see whether the crack is widening or not. Then delamination, as I said, that either tapping test or chain dragging can be used. Spalling and exposed reinforcement or full depth hole, you can see the visual check. So IRC SP40 that gives the guideline on repair, strengthening and rehabilitation of concrete bridges or bridge components. But some of the NDT tests like which are widely used are core testing, but accuracy of strength is on the higher side, but the lack of damage to the structure is not there because you are taking a core. Then the UPV test, like accuracy is okay, speed is also fast, ease and economy is good, and also you are not damaging the structure. Near to surface, either you can do the pull-out test or penetration resistant test can be done. Immediate surface, you use the rebound hammer, but the accuracy is not that good. Maybe the variation is there plus minus 25%, but you are not damaging the structure, or economy is there, ease and speed of doing the test is there. So this gives you some thing to select what type of test to be done. But what is important is that in the case of composite girder, like what are the additional things to be inspected, like the shear connector, girder connection, whether there is any problem or there is a vertical separation between the girder and slab. So these are important aspects to be seen, but not mentioned in either IRC SP 40 or like IRC SP 74. Now, like we said that we do the mechanical, chemical analysis of the steel to find out what is the element composition. But you have a bridge which is existing, and if you want to know what is the elemental composition, then you can use this handheld XRF. They are compact portable devices, so they can be used to find out the elements like in the steel which you have used. Only thing is that they will not be able to detect the elements which are having like atomic number lower than sodium, like carbon, nitrogen, oxygen, but other elements you can find out. Then another is the dye penetration test, like to identify where the crack is and the location and whether there is a crack or not there. So here, like you surface with the crack that is first cleaned, and then like you apply a penetrant, and then that surface after the removal of the excess penetrant is shown in fold, and then like some developer is put so that like that penetrant is absorbed by this developer, and then like you can see that there is a crack there, but you don't know how deep the crack is, that you will not be able to find, but you can identify that there is a crack, and also like where it is located. So if you see the advantages and disadvantages, visual inspection, that is the lowest cost of all NDTE methods, and immediate data for reviewing and analysis, no need for any costly equipment and training. Only thing like if the inspectors, it all depends on the knowledge of the inspector. So, and also it gives only the surface defects and only able to detect the significant flaw. As I said that when the damage has become quite large, then only you will be able to identify that. And subjectivity in identification of flaw, they are the disadvantages. By dye penetration testing, it is simple and less expensive and rapid method, and proper method for detection of surface cracks in metals and even the weld, etc. But again, it is only limited to surface cracks. Subsurface defects you will not be able to find out, and also some safety hazard in chemical handling and disposal, and impractical for inspection of porous surface because again that will get absorbed this penetrant which we are applying. The another is the magnetic particle method. You can see that where there is no crack, all these lines are parallel, but when there is a crack there is a deviation in the magnetic field lines. So the component has to be pre-cleaned and introduce that magnetic flight, application of magnetic media, and interpretation of magnetic particle indication. That is, if there is any flow that is detected with that. The other methods are the radiographic testing, ultrasonic testing, Actually, the ultrasonic testing, that is very useful because subsurface flaws, even like the slag inclusion, which I said that because that is non-metallic. And the porosity, etc., surface breaking like crack, even like because of the corrosion, you have lost some metal. So the metal thickness can also be measured with the ultrasonic testing. And it is most practical NDT method to detect the planar defect, including crack, lack of fusion, lack of penetration, whatever defects I said in welding, like it is easier to measure. So you can see that there is an angle probe here, and this is the crack, and it is kept at a far away distance. And you can see the initial pulse, that is where it is a sound path, and where there is a defect, then the echo, initial pulse and the defect echo from there, like you can see it in the CRT display. So you can find out where the crack is there, and what is the size of the crack, etc. And it can be used for various applications, for uplift, bearing or anchor bolt, or for the inspection of weld area, butt weld area, and even the pin connectors which we use, there it can be used, or gusset plate, etc. So it has wide application in steel bridges. Another is the acoustic emission method. Basically, this is relates to the elastic waves generated by the sudden redistribution of stress in material. That is, when there is a crack happening, then there is a redistribution of stress. So the waves generated, they are different. So it helps to monitor the crack. That is the initiation and propagation of the fatigue cracks that can trigger the acoustic emission. So basically, this is important in the sense it gives valuable information regarding the origin and importance of discontinuity in a material, and it can be carried out online, requiring only limited time. That is another important aspect, and it helps to identify the affected region of crack, which are if the area is invisible, then also like this method can be used. Another important test is the infrared thermography testing. As you can see, this infrared camera, like you can find out there is a web and flange, and there is a weld here. So the weld root, if there is a crack there, that can be monitored using this infrared camera. So if you make a comparison, you can see that like the equipment and inspection cost and how good the results are. The optical method, like the equipment cost is like A is having highest cost and D is lowest cost. So either B or D, and inspection cost is also least in this case. Radiography basically needs a costly equipment, but inspection cost is not that much. Ultrasonic against not that costly. Like magnetic particle also not that costly. Penetrant flow, that is the cheapest one. And so this gives you how to select them, and also where like it can be used. So basically the NDT advantages are that like it evaluates the surface and internal condition, because we say that NDT is available for surface flows as well as subsurface flows, can test in service structure without destroying that, because we saw the destructive test also, that is the initial stage, okay? And cost efficient and reliability, that is measurements are made indirectly and qualitative and required. Actually, this is very important. Actually, it requires skilled professional for interpretation of the results. That is important. So the performance-based qualifications are required for the people who are going to do the NDT test. So level 1 and level 2 technicians can be there. So the training, skill training is required for the people who are going to do this NDT testing. So level 1, actually, if they are qualified only for level 1, they can do setup of NDT equipment, perform the test, record and classify the results of the test in terms of the written criteria and report the result. But who is going to decide what type of test to be done, or like translate the NDT codes or standards, or the how the interpretation of the result is done? That is all done by the level 2 technician. So please see that whom you are engaging and what is the level of skill they have earned. That is also important. Now coming quickly to the repair strategies, basically the classification of repair methods for steel. Actually, as I said that the protective coating is very important, but that is you can say it is a minor repair if it is you are doing only at a local area, or like even if you are doing it for a repainting over a large surface area and also replacing some bolt, nut, etc., that is a minor repair. Preventive repair comes as the anti-corrosion painting if you are using, that is a preventive one. And basically that is to prevent the steel from corrosion. Then major repair is some replacement of steel bridge member, or painting some complex structure, or some steel plate bonding to be done like that. And again, like some preventive measures are there, like something like stop hole, introducing that. So we have to see like what type of repair is to be used in what situation. So as I said that this protective coating like paint, if it is peel off, and if the peel off area is less than 10%, not much any action to be done. But between 10 to 30% peel off area, then that particular local area can be painted. If the area is more than 30%, then the repainting to be done. So this gives you a guidance like what action to be taken, that what decision to be taken based on the type of defect what you are seeing. Then if the steel structure corrosion, that is I said that the corrosion section loss can be measured with ultrasonic testing. So if again the section loss is less than 10%, you can do repainting, and if it is 10 to 30%, then the repainting with anti-corrosion paint. But if there is a section loss of more than 30%, then not only the repainting, but also some steel plate bonding has to be done, because the area which is effective in taking the load, that has reduced. So some steel plate bonding is required. So the corrosion, first we have to see whether the corrosion is with section loss, without section loss. Without section loss means like you can do a local painting, but with section loss, depending upon the area of section loss, like you have to decide whether it is only repainting, or repainting with an anti-corrosive paint, or repainting and steel plate bonding. Another important aspect is, here I hope you can see that there is a crack seen here. Actually, as I said that we don't expect any crack in steel bridge component, especially the primary component. But if there is a crack is there, then what action to be taken immediately is to prevent the progression of that crack. How that can be done is you have to introduce a stop hole. So you can drill a hole, and that is a countermeasure against the fatigue crack, and that will reduce the stress concentration at the edge of the hole. So the crack occurring in isolated location can be repaired by drilling a hole, and the diameter of the hole is between 13.5 to 23.5 mm diameter, at about 20 mm beyond the crack. If you do that, then that will stop further progressing of the crack. But if it is a primary member, like you can do a steel plate bonding apart from this introducing the stop hole with the help of an electric drill. And if it is a secondary member, like that member can be replaced. and steel which is strong in tension but weak in compression, so that can buckle, and there could be some crack develop or some deformation happening. In such case, replacement of member is suggested. Similarly, the loose or you can say some missing bolts or even rivets are missing, then the bolt can be used as a replacement. So these are the situation where you have to do a replacement. Now, like how to restore the composite action? As I said that like steel and concrete, they are connected through the shear connector. So, and there is a separation of concrete deck slab from steel girder. So if that is noticed, like you identify the location and mark it with some separate paint, then first identify why that has happened. So the because generally we do all this investigation to find out why this defect has happened, because the solution or the remedial measure that depends on root cause. So the possible solutions are the epoxy grouting, that is first thing. But if that is not solving the problem, then another is vertical pre-stressing and strapping. That is through vertical pre-stressing, the steel and concrete, they are connected. So these are the solution to restore the composite action. So coming to the conclusion, that the quality control of steel concrete composite bridge decks that help to reduce the defects, and testing of shear connectors, like it is mentioned in IRC 22, the push-out test to be done, or even the mechanical properties to be tested, etc. But that is not found in practice in the field. But I think that has to be, we need to follow that. And NDTE is used not only for the assessment of in-service steel concrete composite bridge decks, but also during fabrication also. Again, identifying the right NDT method, and also using a skilled person that should be carried out, and also the interpretation of result is important. IRC 74, that will have to be revised because that is prepared in 2007, though prepared document, but that can be modified by including some advanced NDT methods, how to select that, and selection criteria for repair strategies, etc. And as I said that we have separate guideline for steel and separate for concrete, but not for composite. So maybe for steel concrete composite bridge decks, how to do the repair, one document can be prepared. So this is all from my side. Thank you for your patience hearing. And if you have any questions, I'll be happy to take that. Thank you.
Thank you, ma'am, for such a wonderful, difficult topic and explained so nicely. Before I ask for a few questions, I just want to know what is the CVN value? And the
CVN is, it is the Charpy Vinos test value for steel. Yeah.
And secondly, what main things that we need to add in this IRC 74? Just 2-3 things which you feel
IRC 74, it is basically for repair, strengthening, etc. So there, for the it is only for steel bridges. So steel components it is given, but for steel concrete components, whether the composite action is intact or not, and how the repair method, how that can be decided, that strategy can be included there.
Right. Thank you, ma'am. Vikas, just 3-4 questions now, because time is. The other fellow can send the mail, and so just 3-4 questions, please ask.
Okay. Yes, sir. There are a few questions. First question is by Mr. Vinay Gupta. He said shear studs are connected using a special stud welding instrument. He wants to ask how do we test the shear studs for their actual strength of connection?
Yeah, actually, whether the welding has been done properly or not, that for that the ring test and that bending test that has been specified. And then even IRC 22 specifies that like the push out test to be carried out. But I have not seen the people doing that, but it is written that it has to be carried out. So the push out test will be the one which will give the actual strength of the connection.
Okay, thank you. Thank you, ma'am. There is another question. How could we check the commercial material used for corrosion inhibition to be added in is okay or not? Satyendra Kumar, I think so. How could we check the commercial material used for corrosion inhibition to be added in this?
Added in, not very clear.
Yeah, ma'am. I think it is not very clear.
Yeah, maybe I can discuss with him later.
Right.
Okay, ma'am.
Yeah.
The next question.
Yeah, there is a last question I'll take up. Ms. Arpita Ghosh, you mentioned that camber loss has to be checked. Could you
Yes.
please elaborate on this, specifically in the case of composite bridge, steel girder with concrete deck? What is the significance of camber loss and how it is evaluated during construction and service life? Moreover, if negative chamber, that is download, camber, a download deflection instead of intended upward camber is observed, how it is dealt with also if the max negative camber value is within allowed deflection?
Actually, the camber is provided for bridges with more than, I think, 30-35 meter span. Like, so that like because if you see the deflection due to dead load of the bridge, that is much more than that of the live load. So you provide a camber so that the dead load deflection is compensated. That is why you are providing the camber. But if the camber is lost, means like there could be how it can be monitored is like the deformation measurement. Even with naked eye, you can see that whether the bridge is in the deformed position or it is in a straight position. So you can find out without much problem, and also you can use some what you can say level etc. that can be used to measure the deformation if there any of the bridge. So if negative camber, that is downward deflection, that means like how it is dealt with if maximum, that part I am not able to understand. If Madam Arpita can contact me, I will be able to answer that. That part is not clear to me.
Madam, we thank you very much for
Thank you, sir.
sparing your valuable time.
Yes.
I will just summarize that in such an important webinar. She mainly explained to us by use of non-destructive test and evaluation, we could assess the condition of the composite decks, can identify the cause of defects, prioritize and then repair, timely repair, stitching time, save 9. So this is the important thing. Then she said that upgradation of skill of workers, technicians, and then the stress and the such work, the quality cannot be compromised. So proper quality control. And now she finally said that this IRC 74 is being revised, where the composite steel bridge will also be part of that. So really great. We are thankful on behalf of Indian National Secretariat. I thank you, ma'am, for sparing your valuable time and sharing your experience. So we organize such lectures every month. So next month, another speaker, another topic. So please make use of such things. that will really help the young structural engineers in their career. So, madam, thank you once again. Thank you so much.
I request Vikas if he can send these questions which are there in the chat box to me. That will help me.
Sure.
Yeah.
Sure, ma'am. Sure.
Yeah. Thank you. Thank you all participants for your valuable questions which you have raised. Some of that I could answer, but I'll be answering the other one also. Thank you very much.